Hi, and welcome back to Get Started with React Native. In this lesson, we will have a look at React Native APIs, especially the geolocation API. APIs in React Native provide access to features that are not necessarily components, but are important platform features. An example would be an alert that gets displayed on the screen, or the possibility to make the device vibrate. Some APIs are platform specific and have the suffix iOS or Android in the name. Before we have a look at the geolocation API, let's look at some other useful APIs. First up, NetInfo. It fetches the current connectivity status of the device and displays the type of connection it currently has. On iOS, it is limited to none, cell, and Wi-Fi. But on Android, you can get a big variety of additional types like Ethernet, Bluetooth, or VPN. If the quality changes, an event will be triggered and you can change your user interface accordingly. The second API that you might want to use in your app is Async Storage. It provides a simple and persistent key value store. Async Storage allows you to set, get, and remove items from the store by using a key. If you are storing JSON, you can also merge values together. All those functions are also available to handle multiple keys at once. Very handy. But now let's switch to the geolocation API, which will be part of our COS project. This API is very simple. It only has 4 functions: get current position, watch position, clear watch, and stop observing. The first 3 functions are also part of the geolocation API you can use in your browser. To use the user's location, you have to add the NS location when in use usage description key to info.plist, which is automatically done for you during React Native init. If you want to use the location in the background, you have to add this to your capabilities and include the NS location always usage description key. Normally, these keys should contain a description why the app wants your location. On Android, you need to add the user's permission to access find location to your Android manifest XML. To continuously watch the location for updates, you use watch position and add a callback to it. You can also add a timeout, enable high accuracy, or only receive significant updates by adding distance filter. If you are done watching, use clear watch for the observer instead of stop observing, because this will stop it app-wide. Okay, it's implementation time. Geolocation doesn't need to be imported. It can be used through the navigator.geolocation polyfill. In the constructor, I'm going to add a call to watch position on the geolocation object, which receives a callback with a position. Here, I'm going to use the same logic that we had last lesson and add a marker with the coordinates and the key. I'm also going to add a distance filter of 10 meters, so we don't get too many updates. I also want the watch ID from the listener, so I can set it to the state. It's not important here, since we are dealing with the root component, but I wanted to show you how it's done. Let's add another method called component will unmount. It will get a call to geolocation stopwatch and get past the stored watch ID. This will delete the listener when the component gets removed from the DOM. With that in place, as a first step, let's remove the follows user location and on region change from the last lesson and try it out. It already works with markers. Now let's change it to draw a line. To do this, we need to swap out the marker with a polyline component. It takes an array of coordinates, which we can build by using map on the markers, and return the coordinate for each. Let's also add a thicker line. Here you go. The line is drawn successfully. Now it's time to get the distance, speed and direction. I'm going to start with speed, since it's the easiest. It's available directly from the position attribute as position.coords.speed. Let's set that to the value of speed info. The direction is also available directly, but as a heading number, not a bearing. I'm going to paste in the code for this, since it's quite tedious to write. Here you go. If the position.coords heading value is between one of those values, it shows the correct bearing. Now, calculating the distance is a different story. When you want to do it correctly, you have to use the haveAssign formula. Luckily, there is a JavaScript module that does exactly that. We can easily install it with yarn and then restart the packager. To use it, just import haveAssign at the top. To make the calculation easier, I'm going to calculate the distance based on the previous coordinates and store the results in the component state. Using the haveAssign function with the previous and current coordinates, we can do the calculation and add it to the previous value. haveAssign defaults to kilometers, but you can also change it to meters or miles. Great! Now we have a working tracking app that also shows distance traveled, current speed, and direction. To recap, React Native APIs allow access to platform features that aren't components. Platform-specific APIs have the iOS or Android suffix in the name. NetInfo and async storage are two important APIs you should be aware of. Geolocation can continuously inform you about updates with watch position. It can be used through navigator.geolocation. In the next lesson, we are going to look at Redux and how to store application state with it. See you there!